Hi, this is Mr. McGovern, and this is the fifth video in the Momentum and Impulse series, and this one is looking at the concept of impulse. So we're going to look at another little collision, and this time I'm going to add something to one of the cars.
I'm going to do the same experiment again from the start, where they have the same masses and the same speed. So here they come. And what you notice is they've got bumpers on the front. I'm going to take one of the bumpers off, and I'm going to replace that with, this is just a piece of plastic, but it compresses quite easily. So you can think of it as a spring on the front of one of the cars, or even a crumple zone that you've seen on a car or heard about from your physics teacher. So when I get this on here, when it collides, you can see that when it collides, it compresses a lot more than the other one. So what happens now when we do the same speed, but one of them has a bumper on there? So record, here we go.
Okay, so within that collision, when we hadn't added the bumper, we had a force diagram like this, two sharp peaks. When we added the bumper, what we saw was that the collision took more time. These forces are spread out over a larger time, and the peak force is less. The forces between the two are still equal, between the two cars. It's still a symmetrical diagram, but that peak forces are much less. So why is that? It's due to the concept of impulse. So impulse has the symbol J, and the formula J is change in momentum. That's change in P, or triangle P, and it's also equal to force times change in time. So because it's equal to these two concepts, either change in momentum and force change in time, we often just write it without the J. And we just say that the change in momentum is equal to the force times the change in time. So in both our collisions, the first one without the bumper and the second one with the bumper, the change in momentum was the same. They both went in from the same speed and then bounced back at some new speed. So the impulse in both of these cases was the same. However, when we had the bumper on it, there was a larger collision time, and that meant a smaller force. So another way to do it is to look at the formula and say when there is a larger collision time, there's going to be a much smaller force because the change in momentum is the same.